Okay, so they give us a function f, and they give us the general term, but they want us to find the interval of convergence for big F, which is the antiderivative of little f. So what I'm going to do is I'm going to go ahead and take this antiderivative so I can integrate the general term. So that's going to give me, this is just the number. The variable is t, right, which is really like your x, okay? So if we want to do it in terms of x, let's just make it x. So the rule is we add 1, divide by the power. So this would be your general term for big F of x. So we're going to go ahead and use the ratio test on here. And ratio test says that we're going to take the n plus first term. And be careful, you need to plug in an n plus 1 wherever there's an n. So it's going to go in parentheses like this here. And then we're going to multiply by the reciprocal. Okay, a couple things are going to happen here. This is going to become unimportant because we're going to take the absolute value of -1, which is always 1. I'm going to go ahead and simplify a couple things. I'm going to multiply at that 2n plus 1 plus 1. That's really x to the 2n plus 3 here. So I'll make that 2n plus 3. Okay, notice what happens. First of all, the 4's we can go ahead and cancel out. The x to the 2n piece will drop out. So really you have an x cubed on the top and an x to the first on the bottom. So really you're just left with an x squared on the top. So this is how we can clean it up. And now when we take the limit, we're left with just the x squared. And we know ratio test says it converges if it's less than 1. You can go and take the square root, and this is how we're going to solve it. So, but since we use the ratio test, I do need to check the endpoints. So let's start with x equals 1. And remember, I'm going to plug it back into the very original that I started with, that I did the ratio test on. And if you do that, you're going to end up with this. 1 to the 2n plus 1 is just 1. So really, I can write it like this. And remember, we talked about if you have an alternating series and all you have is n's on the bottom, the 4 and the 2 and the 1 are important. I know it's going to converge by the alternating series test. If you do -1, same thing's going to happen. You end up with this. And when you plug in 1, 2, 3 for n, you're going to notice this is also an alternating series still. So same thing happens here. So alternating series test also converges. So it's going to converge at both endpoints.